Moving on to example 3. In a Queensland town, historically 62% of all births are girls. Calculate the probability that in the next 8 births, exactly half are girls. So we want to calculate the probability that X equals 4 in a system where N equals 8 and P equals 0.62. So if we needed to write this out in full and not just use our calculator, and if we were doing this, we would probably write this line anyway, it would be 8C4 times by the probability of success 0.62 to the power of 4 times by the probability of failure 0.38 to the power of 4, and then we just get our answer from the calculator. And it's always going to look like this. In this case, it's a point distribution, so I'm going to go BPD, and I want 4 in a situation where there's 8 and the probability of success is 0.62, and that gives me 0.2157. So 0.2157, and it will seem I didn't need that much space underneath there. But there we have an example where you can apply that. But just keep in mind, unless this was a 1-mark question or a multiple choice question in your external, I would definitely be showing that line and this working, just to make sure that you get the full working marks. And example 4 is a complex familiar question, which asks in 2 parts, which have been labelled poorly. So let's make that a 2. Along a stretch of road on my way to school, there are 5 traffic lights. They operate independently and are green for 25 seconds before being red for 85 seconds. Find the probability that I stop at 1 traffic light on Monday morning. So let's define some things first. X is going to be approximately equal to the situation, which is going to be equal to the number of traffic lights, let's just call them TL to save time, that I stop at. So that means therefore that N is equal to 5. There are 5 in total I could stop at, and the probability of success is equal to 85 over 110. And it seems a little bit counterintuitive that we would talk about the probability of success being stopping at a traffic light, but that is the way it is, and we have to define our system mathematically rather than the way we think is more intuitive. And we're talking about the number of traffic lights we stop at. 85 is the time that a traffic light is red, whereas 110 is the total time of a cycle, 85 plus 25. So we've got a calculation there, and it's pretty easy from here. The probability that I stop at 1 traffic light on Monday morning is the probability that X equals 1, and this will be equal to 5C1 times by 85 over 110 to the power of 1 times by 25 over 110 to the power of 4, and again I can just put this it's a point distribution, so it's BPD. I want 1 success out of 5 trials, and it's 85 over 110, and I get 0.0103 as my 4 decimal points. 0.0103, so about 1%, which makes sense because I'm really quite likely to stop at a traffic light. Question 2, the probability that I stop at 4 or 5 is X is greater than or equal to 4, and this is the probability that X equals 4 plus the probability that X equals 5, but I'm going to do this straight in the calculator again, and so this is a BCD question. 4 is my lower bound, 5 is my upper bound. There are 5 events, and probability of success is 85 over 110, and that gives me 0.6807. 6807. And then question 3, I stop at 1 or more traffic lights. So the probability that X is greater than or equal to 1. Now keep in mind this is equal to the 1 minus the probability that X is less than or that X is equal to 0. And so I might do it that way. I don't have to. If I do 1 minus BPD, 0, 5, and then 85 over 110, I'm expecting this to be fairly high, and I get 0.9994. 0.9994. So that's question 1, which I've labelled again quite poorly. So let's write that out and put A, B, C. And then question 2, I have 34 more days at school. what is the probability that on at least 10 of these days I will get to school without stopping at any traffic lights? So y is the distribution as in the number of days I hit no traffic lights, which actually we know to be quite unlikely. So this probability is probably going to be quite small, but I want the probability that y is greater than or equal to 10. And this will be equal to 34 C10 times by p to the power of, greater than or equal to, it's going to be a CD, so there's lots of stuff there. Probably that y equals 10, probably that y equals 11, probably that y equals 12, etc. But more importantly, I know that n equals 34, and I know that p is equal to the probability of stopping at no traffic lights, so without stopping at any traffic lights, which is equal to the probability that x equals 0 in our previous design. And so if I work out the probability that x equals 0 by saying BPD 0, 5, 85 over 110, close brackets, that's my now p value, my probability of success. But I'm going to do a cumulative probability from 10 to 34 for 34 events with that p value to calculate this. So it's a BCD. I want the probability that I stop at no traffic lights between 10 and 34 times. There are 34 events, and my probability of success is the answer to the previous question. So I go shift answer, close brackets, and that gives me a really small number, let's say 696. So equal to 8.696 times 10 to the negative 25, which indicates a fairly poorly designed question, but it's telling me that's massively unlikely that I will get away with 10 or more days of not stopping at a traffic light, because that 10 to the negative 25 means essentially there's 24 zeros in front of here before the decimal point, so massively unlikely. Anyway, that's the end of our work on binomial probability just as a calculating tool. We have a little bit more left in this topic though, which I'm going to run through in future videos. All the best.